Hi, and welcome to the talk today on how ARM is advancing Android gaming in the cloud. My name is Nick Cook, and I'm a Senior Principal Solutions Architect at ARM. My main areas of interest are in cloud enablement of workloads using ARM-based processors, and particularly around the cloud gaming environment. As an overview of what we will talk about today, we will start by having an introduction to ARM, and then we will look at two different types of gaming environment. The first is network multiplayer gaming using ARM-based game servers, and the second is cloud gaming focusing on Android in the cloud. Finally, we will take a look at some partner solutions that are providing Android in the cloud. ARM is an IP business, so we don't make the actual processors that go into the devices or into the servers. What we do is we produce the designs, and our ecosystems of partners deliver those designs with their added value to provide the capabilities. We also work with a wide variety of the ecosystem to deliver software solutions that enable developers to deliver the solutions. As you can see, over 180 billion chips based on ARM technology have shipped to date. And those chips are in every type of device, from small IoT sensors through to smartphones and tablets, and into the infrastructure as servers that may be used in 5G or further back towards the data center and in cloud environments. And finally, we're also used in the HPC environment. So the Fugaku system in Japan is based on ARM technology and is the world's #1 high-performance compute in the world. Firstly, looking at network multiplayer gaming. Here, the client runs instances of the game itself, and it will deliver the whole experience to the client through to the gamer. Any game state information that's created is streamed back to a data center. Each of those individual instances are placed into a match or a game where the players are playing with or against each other. The data center runs that match and coordinates all the players' actions. The data center computes what the authoritative state should be and distributes that to all of the connected clients so they have the same information and the same actions and results are provided to each gamer. ARM is an ideal choice for use within the game server in this environment. What we've done is we've produced the Neoverse designs. These are scalable high-performance cores for server applications. So whether you want to use from 8 cores in a remote edge location, such as in a mobile network or closer to the client itself, through to 128 cores in a data center type environment, whether that be private or cloud. The great thing here is that all the optimization that you might have done in the code base for your smartphone or tablet application or game, can be reused because it runs on ARM technology. So you can reuse that optimized code in the game server. You may provide some additional optimizations, but all of the value will already be created can be just directly used on those ARM-based game servers. Having a look at the different type of game servers or general infrastructure that you could use, either you could go with public cloud, a hybrid cloud, or on-premise. Taking a look at some cloud options here, you could use ARM-based Oracle Cloud instances. These are using Ampere A1 compute, where you get 1 to 80 cores per virtual instance. Or you have a bare metal instance of 160 cores and a 1 terabyte of memory. Within the AWS environment, you could go with the ARM-based Graviton 2. This delivers up to 64 virtual CPUs or cores per instance. And the great thing about this is that they are individual cores. So the performance of the workload as you scale up stays more or less linear. The types of environment or instance types you have here are the M6G or C6G, and then the other varieties of R6, T4 and X2GD. And on-premise Graviton 2 based outposts are coming later in 2021. If you go for private hosting, you could go with Ampere Ultra based servers, and these deliver up to 80 cores per CPU, and the 128 core Ultra Max is coming soon. Let's have a look at some of the workloads when running on an ARM Neoverse N1 design. Here we've taken performance per virtual CPU on an M6G, a Graviton 2 AWS instance, and we've compared it to the Intel-based M5 AWS instance. A wide variety of different workloads are represented here, but as you can see, there's an uplift of 24% through to 65% on all these different types of workloads. So whether you take a database running a multi-threaded Redis, you get 165% compared with when running on the M5, through to on-CPU inference where you get 128%. So as you can see, you get this performance uplift per vCPU, but also the instance pricing for the M6G is much better per instance compared to the M5. In order to deliver the game, you'll obviously need an ecosystem of different types of software. So we work with partners to make sure that the AArch64, so AArch64 is the name of the ARM compiled for ARM environment. So you have AArch64 binaries, first class support. So you have CI systems such as Travis, which will run directly on ARM, and you'll be able to find the binaries to be able to put on without having to create them yourself, through to Jenkins as a CI. We've got different types of operating system that you might use, whether it be Ubuntu or Debian, and the delivery of infrastructure. So if you're doing a private infrastructure delivery, we have OpenStack. Finally, things such as databases, as in Redis and MySQL. So there's a wide variety of the different types of software that you might need there that you can just pick up binaries for, and they'll be ready and optimized for AArch64. Finally, if you're an Unreal Engine user, within the delivery of 4.27, you will be able to deliver dedicated servers for ARM-based server environments. And these have been optimized for ARM 64-bit servers. So now you can not only deliver your capabilities directly, but you've also got your direct game environment available on ARM server as well. Let's move on to cloud gaming and have a look at the architecture here. Within cloud gaming, instances of the game are run in the data center. The graphics processing is all done here as well in most environments. And this delivers the final render and encoding of a video stream that needs to be streamed down to the client and presented to the gamer. If edge locations are available to you, there is the potential to locate some of the processing closer to the client. This provides lower latency. And once that visual stream has reached the client will decode it and provides the visual to the gamer. And the actions that the gamer performs are streamed back to the network server instances so they can be computed and the relevant graphic stream can be created. Android in the cloud is a particular example of cloud gaming, and this is where instances of Android are running in the data center. Now, this type of environment is becoming quite popular so that game developers can reach more devices. Now, obviously, not everybody's got the very latest devices, and you want to target some of the latest titles towards a wide variety of users. This can be done with Android in the cloud. You run the cloud instance, you run the Android instance in the cloud, and then you're streaming the results to the clients. So many more different types of clients can be involved in that type of interaction. You can also target different devices other than mobile, because you're now looking at video decode rather than actually having a computer game on the client itself. And finally, you can provide continuous play across different devices. So you can play on one device and pick up on a different device where you left off previously. But within Android games, you tend to have a large component of native code, and this has been optimized for a particular architecture. So you could go with binary translation to convert from ARM to another architecture, but it adds an overhead, it's complex, and slows down the experience. But with ARM-based game servers, you don't need to, so why not just run them on ARM-based servers directly? There's no need for binary translation here, and all the investment you've made in your Android game can be reused. So, Android games in this type of environment using the ARM-based server run natively inside containerized or virtualized instances of Android. On the right here we can see a generic stack using the ARM-based server, a kernel, and LXD containers, and within each of the containers we have the Android instance. Environments or server types that you could use for this are available from data center through to the edge. So again, you could use an Ampere Ultra with NVIDIA GPU, and you get up to 80 cores of the ARM 64-bit compute here. Or it's also been announced that AWS Graviton 2 and NVIDIA with NVIDIA GPUs will be coming. What we'll do next is we're going to look at different partner solutions that are delivering Android in the cloud. Within Anbox Cloud, they're using the ARM-based server platforms with the NVIDIA GPUs and Ubuntu. They have LXD containers with the Android container instances, and they have a set of services to enable this environment to work. The results are streamed over WebRTC or H.264. This provides a high density for a low cost per user, and you can run it yourself or in a public cloud. This has been accelerated using the NVIDIA GPUs and is obviously optimized for these ARM servers. You also get the enterprise support 24/7 from the environment. Anbox is delivered from Canonical. Another type of environment is provided by Genymotion. Genymotion is targeting Android as a service developers. So less specifically than providing the applications themselves, Genymotion is giving you an environment that enables you to go through your full app life cycle and go through automation with the CI/CD tools and have a virtual mobile infrastructure to enable you to run your applications and verify, validate, and examine them all the way throughout their life cycle. Now this is available today using the AWS Marketplace, and you can target the ARM Neoverse AWS Graviton 2 with that. So that's ARM-based servers. And it's also been announced that it will be coming soon to the Oracle Cloud infrastructure using the ARM-based instances that have been announced there as well. Another type of environment is provided by a company called Nothing to Install. This is different to the others environments where there are no graphics compute requirements on the server side, so there's no GPU here. What you have is an ARM-based server, and you put your existing Android application, so there's no need to change the Android application, and within their patented technologies they have an end-to-end stream that streams the result of the computation across to the client, and the client works with on the GPU side to deliver the actual final rendering. Now this is available through a native client, such as you might use on an Android device, or to provide it through a browser type environment using the browser client and using through WebGL in this instance. In both cases, on the server side, we're running the ARM-based servers. Now we'll hand over for a deep presentation into now.gg. So I'd like to hand over to the CEO of now.gg, Rosen Sharma, to provide that presentation to you. Thank you.
Hi everyone, I'm Rosen Sharma. I'm President and CEO of Now.gg, and today I'm going to talk about how we are bringing mobile gaming to the next billion people. If you look around you, everybody's on their phones, right? There are 5 billion people in the world on the phones, and more than 2 billion of them play more games every day on their phone, right? And all these phones, whether it's an Android phone or iOS phone, run an ARM processor. So we have developed some really cool technology working with ARM. And we have developed a new operating system we call the Now Cloud OS, and it runs on ARM powered servers in the cloud. And we're going to talk today about how this revolutionizes the mobile space and also the data center space and what's coming next in the next decade. If you look in 2010, there was nobody playing mobile games. The mobile game market was zero. Today, the mobile game market in 10 years later is $120 billion and growing over 20% a year. There is no other sector of entertainment which is growing as fast or has become as big. Mobile games themselves, as compared to PC gaming, mobile gaming is 120 billion, PC gaming is 35 billion. Console gaming is another 25 billion on top of it. So mobile gaming, PC, console, all combined is still only half of mobile gaming and not growing at the same rate as mobile gaming. And now we are talking about how to bring mobile games to the next billion people, right? And so with Now.gg we have done is we have developed the mobile cloud. And what this enables game developers to do is take their existing mobile games and put them on the cloud, and also to build cloud native games in the future. So the first thing it does is it's accessibility. If you look today, 60% of phones sold worldwide are phones, mid-tier phones which can't run your modern day games, right? Like Fortnite or PUBG or Genshin Impact. And on the other hand, if you have kids at home who play games, they have their power cord attached to the phone, so the battery doesn't run out and the phone runs on high performance, right? So both ends of the spectrum, the accessibility, the power of the device, kind of limits what kind of games you can play and who can play those games. So by running these games in the cloud, you unlock this huge set of users, in the world who can now access any type of game using the cloud. That's one aspect of accessibility. Another aspect of accessibility is time. I play games. If I played a game last year and a new update of it came this year, I'm kind of reluctant to go download the game, download all its updates and try it. But if it was just one click away, then it's so easy, from a time perspective, one click to play the game and experience the new version of the game, makes it much more accessible from a time perspective. So I think this bringing mobile games to the cloud not only changes the accessibility from a device perspective, but it also changes accessibility from a time perspective. And I have 4 daughters, and they are constantly on social media, right? And the kids of today are on Discord, Snapchat, WhatsApp, Instagram, Facebook. Facebook is for older people now, but they are on social media constantly. So one of the things bringing these games to the cloud does is that if I send you a game as a link on Discord, you can play it right in the Discord app. Or if I send you on Snapchat, you can play it right in Snapchat app. So game almost becomes like a meme. And that is huge in how the young people are discovering games and apps today. So now the games just become like memes you can share on social media, and we have optimized a lot for these games to be available and played within the current social media context. Lastly, I have an 18-year-old and she doesn't have a credit card, but she has a Venmo account, right? So kids and many people around the world are getting digital wallets way before they're getting credit cards. And to enable payments and other infrastructure, like Bitcoin, Venmo, PayPal, PayPay, Paytm, Kakao Pay around the world, these digital wallets, and to bring those payments to pay for inside games in the cloud, that completely changes, the nature and the accessibility of who can make payments in the cloud. So we are bringing all of this in Now.gg. But I have to talk to you why Now.gg is possible now and why it was not possible, 5 years ago or 6 years ago. We actually have been working on this from 2017. In 2016, Amazon made acquisition of a ARM company in Israel called Annapurna. And in 2018, they began rolling out ARM servers across the globe. And this is very, very key, because if you think about, in the 90s, we had all this PC infrastructure, and from the PC infrastructure came the current cloud, which is all running on Intel servers. Now you think about billions and billions of phones, which did not exist before 2007 or 2009. Over the last 10 years, we have, 4 or 5 billion phones now in the world. So it's very natural that since those phones run on ARM, we need an ARM cloud to run the apps that run on the phone in the data center. And I think this is a key, when I look at the next decade, all these apps that run on the phone are going to come in the cloud. And it's just natural. It's the natural evolution of what has happened in the other computing spaces, right? And if you look at today, what was available in the cloud worldwide, we had to solve some very, very fundamental problems. How do you do graphics? How do you do compute? The cloud is distributed. Some nodes are near you, some nodes are further away from you. Depending on the time of the day, the bandwidth may be different. So we developed what we call Now Cloud OS. And the first innovation in Now Cloud OS was what we call distributed Android. Right? So normally, if you think of the Android operating system, it runs on one phone or it runs on one device, right? But in the cloud, we took that and we broke it up, and now Android can run on many different machines across the cloud. And it harnesses the power of the cloud. It unlocks, you're not constrained by one processor or two processor or one GPU or two GPU, or doing other kinds of processing. So it unlocks the power of the cloud. So that was our first innovation, which we call distributed Android. It enabled the whole Android ecosystem to come from phones onto the cloud. And the beauty of it is that it can move processing dynamically, like it can move some processing near you, it can move some processing away from you. Just depends upon where you are and what you're doing, right? That was the first innovation. The second innovation is what we call building cloud native apps. So the first generation of apps came from mobile apps. The second generation of apps that we see, which some of them are going to come out in Q3, are what we call cloud native apps. These are built for the cloud first, right? The simple examples of this are apps like you no longer have to worry about what graphics is the phone using. Like today, developers, when they develop their games, you can see it riddled with, if it's a Samsung phone, I can run higher frame rate. If it's a lower quality phone, I have to lower my frame rate. I don't have to show that much fidelity in the grass or in the scenes, right? In the cloud, you're not bounded by these constraints. You can have 100 GB games. You don't need your game to fit into 2 GB or 500 MB. So the things you can do in the cloud are much, much vast, and you can get, really the next level of gaming into the cloud. And so that's the first, what we call cloud native. But also the cloud enables you to do things like, have a metaverse, enable NFTs, and, have user-generated content, enable communities very easily in the context of your current application. So we'll begin to see some of this cloud native functionality that is going to come out. And lastly, we are also working on a concept we call the Infinity Phone. You can imagine a phone that is integrated with the cloud, so it has infinite specs. And I won't talk much about that today, but that is also something we are working closely with ARM with. So all these technologies together and our work with ARM is, we have developed the Now Cloud OS, which is unlocking, the capability of reaching the next billion gamers across the world. So we are very excited. This is just beginning of this journey. I think this decade will be defined by ARM in the data center. And so we are very excited to work with ARM. And we are very excited to work with game developers to bring all these games, to the cloud. And, we launched this service very recently, where we already have 25 plus game developers, some of the top game developers around the world, and millions of sessions being served from the cloud to the end users for their games. So please stay tuned. There's more coming in this space, And it's an incredible and exciting journey that we are on. Thank you.